Okay, so we will continue with Bence from Axiflow, and he will tell us how to actually configure your OTel Collector for the real production environment. So, stage is yours.
Yeah, that's correct. Hi, everyone. I'm so excited to be here once again in KCD, Czech and Slovak. I'm going to talk about how you should treat your OpenTelemetry collectors based on my field experience with it working at Axiflow. So, a few things about me. I'm a software engineer at Axiflow. We are mostly working with observability and security-related tasks. I'm a professional collector breaker, and I'm also a maintainer of two CNCF sandbox projects, Bence and the logging operator. If you haven't seen a collector before, it's a very cute being. It simply just receives some data, it performs some processes on it essentially, and finally it exports it somewhere in your most favorite destination. And along the way, you can have connectors to route between your pipelines. You have distinct pipelines per signals like logs, metrics, traces, baggages, and profiles, and so on. And you can have other extensions for storage and authentication. So this is the collector in short. And it's a beautiful process. Like OpenTelemetry is a great solution for observability nowadays, and everyone loves it. The configuration is so simple. You can read through it. It's so beautiful. But until it's just not. So last quarter, a customer came to us. They had a beautiful pipeline. Their tail sampling was working. Their processors were really beautifully configured. And their pipeline was just beautiful. And every 12 minutes, they got an OOMKill. And we started investigating. A few things they did before, they added retries, they added persistent queues, it died with persistent queues, they doubled the memory, it died with double that much memory. And until we looked at the config more in depth, we came to a conclusion that it was not broken. They essentially made their collector broken. So this talk will be about a couple of battle-tested war stories that I've learned along the way, common mistakes that I've seen people make with their collectors, starting with situations where it got OOMKilled, situations on a restart or update, it was losing some data, and the burden of maintaining your OpenTelemetry collector configurations, which is essentially really hard and it can get out of hands if you are managing a widespread cluster. So let's jump in. So first, when you get an OOMKill, it's some infrastructure and DevOps folks treat it as a mystery, but it's actually not. In Kubernetes terms and in the world of Kubernetes, when using OpenTelemetry collectors, you probably set your memory limiter because it's like the first processor in every pipeline is the recommended one. But there is like a small nuance that you need to set the GoMem limit environment variable to 80% of your pods limit. A lot of folks miss that, and well, the kernel will just destroy the process. And obviously, you have your enrichment and other processors that essentially builds up a lot of cache along the way, like Kubernetes attributes, and also on tail sampling, when it needs to cache or buffer a lot of those traces before constructing the whole thing again, and sampling goes along the way. So first of all, how do you fix the memory limiter problem I was talking about? It's really simple. You just give it an environment variable, set it to 80% of your pods limit, and you're good to go. What do you win with it? Well, the memory limiter in itself is like really simple. It just basically periodically checks whether the memory usage of the collector, and if it's too high, it refuses data or forces a garbage collect to reduce the memory consumption, essentially. But in itself won't help you because Ghost garbage collectors defaults are not bound to the workload that is being handled by the collector. So you need to set that GoMem limit so the garbage collection will run at 80% of your pod limit rather than your kernel deciding. It's like a really simple fix. Jumping onto the words of traces, so if you haven't seen a trace, this is a trace. A bunch of spans across time, essentially. If you look at that waterfall diagram there, the root span is like a request made to the API / order post request. And the service did some authorization, it queried the database, it got some things out of the cache, and finally it published an event. So that simply it is. And along the way, it got some attributes, some other metadata information that will make it more simple to debug some issues within your code. But I like to think of spans as like an analogy of an onion, because the outer layer is like, it consists of layers, and the outer layer is like the resource that we enrich with Kubernetes attributes, for example, that I was talking about. Like the service name, the pod name, and the namespace name. You have scope in the middle, which consists of the instrumentation library used, some specific version, and other metadata. And in the lowest layer, you have the span itself, which consists of name, the duration, status, and other attributes that you placed on it. If we are talking about tail sampling, the policy name that triggered during the tail sampling will also be placed on the span itself. So, and since Kubernetes attributes enriches the outer layer itself, and if that cache can blow up, eventually it will be bad for your traces and bad for your tail sampling. So that's why we care about it. So now we understand the trace. Why do we care about that, and how it connects to memory consumption? So the problem that I was starting off with was coming from a tail sampling problem, and with the GoMem limit, but that was another thing, and it's connected. So what happens with tail sampling is tail sampling will hold your traces in memory until your decision wait time, and once that is hit, then it will just fill out the buffer. But eventually, if you have a constant load of traces coming in, that buffer size will be a constant memory limit that you are constantly will be hitting. So in my silly example, if you have 1,000 traces per second and you have 60 seconds of decision wait time, and you have a heuristic that you can calculate based on that blog that I encourage you to read, in my example, that's 20 kilobytes. If you count that, that's 1.2 gigabytes constantly in your buffer alone. And that's that basically the whole formula is not going to save you. What will save you is if you configure your GoMem limit and your memory limiter based on this calculation. And the formula will just tell you what kind of seat belt do you need. And so it won't trip every 5 minutes or so. So if you didn't do this math, you just basically didn't enable tail sampling. You just scheduled an OOMKill, and your tracing will be so sad. So I found this is like a really simple tail sampling example. The tail samplings that I've seen on our customer side were more robust and a lot more interesting. But in simple terms, this is what you should start off with. So what do you care about within your trace? So the first thing you care about is essentially your errors, obviously, the slow calls what's happening to your system, and obviously to have some information about how healthy the system is in itself, and how well is your tail sampling itself working. You should sample the rest of those. So this is what you can see here. And with settings like this, you can save around 60 to 95% of cost, depending on your error rate, and while keeping all the critical traces. One addition that I would like to make here is that I have seen many tail samplings where people only use the probabilistic type of tail sampling. It's an interesting one because probabilistic is one of the most useful policy types on its own. But if you're only using that type, you should stick with the probabilistic sampler processor, because it's a lot better. It doesn't buffer. It's much cheaper. So essentially, tail sampling worth it if you are using other types of policies as well. And let's connect everything together with putting in the missing puzzle piece with Kubernetes attributes. So Kubernetes attributes is what will enrich our outer layer, the resource layer, with some metadata that it got from the API server bound to that service account that we use for authentication, because that is connected to a cluster role, and whatever that cluster role has permission to scrape, that's what we are going to use for enriching our data. So for example, if that cluster role does not have a permission to read deployments, then that will be missed out. So, but that is an interesting topic because you can have the least amount of privileges within that service account in that cluster role bound to that service account for resources sake. But another interesting topic on that front is that if you are in a cluster where you have around 200 nodes, so if you are deploying the collector as a daemon set, you have 200 collectors running simultaneously and polling 200 informers along the way. So but you obviously don't want that. You want to limit the nodes or the collector's work to the node which is it working on. And you can do that with the missing piece, the node from Envar, which comes from the downward API. It's on the pod spec. You should definitely set that one. And in that way, your collector will only query from its own node and not everyone's else. So your Kubernetes attributes cache will not blow up. Three things that I've added at the bottom is that the cluster rollback that I was talking about. So limit your permissions. Wait for metadata is an interesting one. It's biased a bit because it adds latency, but it's useful. What it does is that it blocks the collector startup until the Kubernetes API sync finishes, but it can be useful, but obviously it adds latency, and pass-through is a special one that you should consider when you're using gateway agents along the way. And if you connect all of this, and hopefully nothing will blow up because your memory limiter and your environment variables are correct, that's what you get out of this. Instead of having a request that essentially says you nothing about where the problem is, you have something that tells you which pod on which node, which cluster, which deployment is going wrong or having sort of problems. So yeah, that's it for the first package. Essentially, tracing is your friend if set up correctly, but as you have seen, there are like a lot of moving parts around a simple problem within OTel telemetry itself, in the collector itself. The next problem was an interesting one, and you can lose records in many ways, but the most common way you lose your records is by misconfiguring your batching and your sending queues. So taking into example, like if you have some receivers accepting some data and it essentially sent out less than what was received, if a sick term was happening on the fly, well, the problem is that the batch shutdown did not handle sick term historically good. Because the problem with that was that when the receiver got a message, it acknowledges that, and the batch processor holds the records in memory until the batch limit size has been hit. And in the meantime, if it got a sick term, then it didn't drain that buffer. It didn't do anything with it because it was not in sync with the shutdown. So you essentially, all of that records that was in memory are lost. And there was, thankfully, there are two ways out of this, one better and one is like a mediocre one. So as I said, it was not synchronous with the shutdown itself. So in version 1.51, they made it synchronous with the shutdown, the batch shutdown, so with the cleanup. So if you must stay on the batch processor, which is right now not the limited recommended one, because it was moved from the processor side into output batching. So if you must stay, for whatever reason, on the middle upstream processor-based batching, you should definitely be above version 151. But the real solution is a twofold. So as I mentioned, batch processing has been moved to the output side into the sending queue session. There are a lot of benefits to it that I will cover on the next slide. But for this one, as now we have per output batching, essentially, if you pair that with a file storage extension of some sort, if the queue and everything else will be on disk and not in memory. So if a seek term arrives, the disk queue will be drained to the disk and before the processor finishes, and the next run or after you finish your upgrade or restart or something like that, the collector will essentially just pick up where it left off. And simple as that. So it will survive your rolling restarts, your auto scales, and your node drain, and so on. So it's, if you can just move from the processor batching to the output batching, and so on, it will be better for you. And just to see some simple example of what that would look like. So we have a faster output and a slower output. In our example, Loki and let's say an S3-based something output or cold storage one. So what we win out of this output batching is that each of those exporters gets its own output and then own batch config, own retry policy, and so on. So every one of those goodies will be applied to each of those exporters. So why is it good for us? The first place is that in our example, Loki needs fast batches, logs visible in seconds on the dashboard, and so on. Whereas on the cold storage side, on S3, S3 charges you per request. So you want to wait for that big size of a batch to send in. So when Loki essentially bursts or something bad happens to Loki, if we were to use the upstream batching, it would stall the code archive for ourselves too. But since we are having distinct batches or sending queues happening on each of our exporters, independent rack pressure kicks in. So what happens is that each of those exporters will not stall one another. Whereas with the middle output or batch processor in the middle would be the problem is that if Loki would burst, then the other cold storage endpoint would have some bad news for that too. A small caveat on that side is that still the persistent queue writes on dispatch and not on ingest. A small thing you can fiddle with on that front is that some receivers also have persistent storages that you can leverage, and you should definitely do. So make sure you check that one out for if your receivers are supporting any type of storage solution. Now that we made sure that our pipeline is essentially somewhat healthy, we should might as well talk about what are the common ways that you are deploying your collectors and how do you know whether it is alive and kicking. So first and most probably the most frequent deploy approach is the DaemonSet or the agent version, which is essentially your application is directly talking to your collector. Enrichment happens on the collector itself with Kubernetes attributes or any other enrichment processor of type. And the latency between your applications and the collector can be measured in like microseconds. So it's really great. And if you enabled the Kubernetes attributes environment variable that I was talking about, each collector will only see its own node traffic. So definitely do that. On the gateway side, gateway is like, it wins on scenarios where you need a central policy with tail sampling at scale and other responsibilities for example, multi-tenant routing and so on the gateway level itself. So, for example, if you're using tail sampling along the way, all spans of a trace needs to connect at one point, and that should gateway be a good answer for. And how do you know it's alive? Well, I might as well think that next to the memory limiter processor, the health check extension is a no-brainer to put in your config along the way. It's basically it will create an endpoint that your readiness and liveness probes will hit if you are using the open telemetry operator, which you definitely should, because it knows best how to handle your collectors in a Kubernetes environment. If you can allow that and you're not on premises or VM or any other scenarios, you should definitely use the operator. And also for logs and metrics, use info. If the volume hurts, you should turn that down to warn, debug while investigating. And metrics should be on detailed, and you should scrape those. I must say, I have seen metrics endpoint turned on many occasions, and they were not even scraped. So that's a funny one. And now into the real problem. So if you have an OpenTelemetry collector and it's not just a baby config, but it's like a production config itself, it will be big. And my infrastructure folks knows best that you have to maintain that configuration on itself. So let's say you have a bug in that you upgrade it to another version, they made a breaking change, you need to find that. Well, sometimes the logs help you, sometimes don't. Sometimes you have to dwell into the docs, sometimes you just figure it out. But nonetheless, if logs don't help you and the docs don't help you, you are left with your eyes beating on that 360 lines of YAML, or your AI pal helping you out for a small cut. But that's essentially it. But I have some sort of a better idea that I would like to show you. As I said, the OpenTelemetry operator is like a half a success in a Kubernetes environment because it knows best how to handle collectors in Kubernetes. So you're halfway there. But what if you could have a well thought out config based on your Kubernetes knowledge from just like a couple of lines of intent? And that is what I'm going to show you in the upcoming demo that I've prepared for you. So this is the cluster that I'm rocking. It's currently sending into Elastic. I might as well just go through the manifest that we are using. So a few words about the telemetry controller. So the telemetry controller is a Kubernetes operator that essentially configures OpenTelemetry collector custom resources passed to the OpenTelemetry operator itself. And the heavy load of the work after the config generation and the collector itself will be handed to the telemetry controller, and everything else will be passed on to the operator. So the first resource of the telemetry controller is the collector resource itself, where it will be placed and which tenants it watch for. In telemetry controllers' words, the tenant itself is like a being that conducts of many namespaces. You can match on those namespaces based on the labels based on those namespaces, and those are your log sources. So every resource that within your namespace, you are going to essentially cover that with a tenant, and you're going to collect logs from that. And you also have your subscriptions, which is the resource that you give to your customers or your users that can subscribe to a small batch of that tenant's own logs. Subscriptions are really simple. They have an OTel condition and an output that you define somewhere else, which name and in which namespace. In our case, we have 2 tenants, 2 subscriptions, and 4 outputs, 2 outputs per tenant. We have an Elastic one, and we have a shared file archive that is pointed to the same location. And what we have here is that first of all, I would like to show you the configuration itself after you deployed the telemetry controller itself and apply those custom resources. This is essentially the config you are going to end up with, but I'm not going to kill you with this config. I'm just going to paste it into OTel bin because it's a great visualization tool, and this is what you will end up with the telemetry controller. So a few best practices that I have been talking about. We are having the memory limiter as the first processor in every single one of our pipelines. We have essentially that 3 layers of abstraction going on. So the tenants, the subscriptions, and the outputs themselves. In the middle, you can see that we are taking sample metrics on the tenant and on the subscription, and a small batch on the output level as well. We are enriching with Kubernetes attributes. We have a very sophisticated config on it, and also the kube node name, the environment variable magic that I shown you is also there. And we are having file log receivers that, because in Kubernetes words, you know that log management is a non-existent thing by design, essentially, because every single one of your workload logs are getting persistent into war, log, pods, pod UUID, pod namespace, and so on. And you just need to mount that to your collector, and you are going to essentially work with that one. So it's really simple to collect logs in Kubernetes, in my eyes. Enriching them and working with them is another topic. And on the flip side, on the output end, we can see that we have our exporters and so on. One thing I would like to point out is that we are taking like redaction really responsibly. So we are not leaking any secrets within our OpenTelemetry configuration that we are saving as config map into the cluster. We also have the health check endpoint, and if I can show you the OpenTelemetry collector resource itself, I promise it won't be long. We have the liveness probes, the readiness probe, and so on, and the startup probe that I was mentioning that the OpenTelemetry operator injects to the custom resource if you have that health check extension. So the operator knows best how to work with collectors in Kubernetes. And I really wanted to show you a disaster scenario when Elasticsearch goes down, but I found out that they support storage in the interface level, so it's not connected in. So I chose a bad exporter, so I will show that the next time. So as you've seen that config, I didn't write any of that. So the memory limiter was the first processor in every pipeline. The go-mem limit was set and to 80% of the pod limit that's calculated every time that you basically change your configuration. The file storage extension was part on the receiver side and also on the exporter side as well. You had sending queues filled up for all the exporters, Kubernetes attributes fully configured, and you write only 50 lines of YAML. So life is great with the telemetry controller. So a couple of take-homes for you. Tail sampling is a really pesky one, and it's really easy to get that wrong. So be cautious with that. Keep the best practices. Keep errors. Keep slow. Sample the rest, and build from there. Everyone will become better at tail sampling once they start using it and seeing it in action. Plus, the memory limiter is really important, and the go-mem limit part is also. So keep an eye on that. Kubernetes attributes, if you are in the Kubernetes settings, enrich for good, filter node local for your costs and your own sanity, and per output batching, move to it if you haven't already, because the processor-based batching has been deprecated. So make sure to do that, and enable file storage on the exporter and also on the receiver side if you can. There was like a really few things that we didn't cover in this one. Airbag for Kubernetes, we barely touched on that. Multi-cluster gateways is a hot topic that I'm working on nowadays, and also back pressure and retries. I have a blog on that on the Axoflow blog, so check that out if you are interested. And if you want to talk about any of those, please catch me in the hallway and let's talk about that. So thanks everyone for listening to me. You can find my socials over here. If you're interested in the telemetry controller and the demo that I've shown you, you can find it over here. It's completely open source. It's part of kublogging and the CNCF, per to say. I don't know if everyone got it. Thanks. And also, thanks or congratulations to the OpenTelemetry team for the graduation. Yeah, I know it just recently happened, so I just wanted to shout out. And one last thing, if you could just rate my talk in here. It's a simple application that lets you rate my talk, so I would be glad to get your feedbacks on this. So yeah, thanks guys.